Good day. Today we're going to be talking about the compound angle identities, and we're going to specifically talk about the cosine one. So as you can see on the board, we have cos into alpha minus beta, which is equals to cos alpha times cos beta plus sin alpha times sin beta. So we're going to prove that what you have on the left has to give you what's on the right. So we're basically going to prove that the left-hand side is equal to the right-hand side. And then now, in order for us to prove this angle, to prove this compound angle rather, you'll need to know the distance formula, as I've indicated here, and then also the cosine rule, which is indicated here. So it's very important that you know these two and you know how to apply them. And then in addition to these two formulas, you also need to use this diagram here. So let me take you through this diagram as to help you understand what's going on here. So here we have the following information. We have a circle with a diameter with a radius that is equals to 1. So the radius, as you can see from here to there, is 1. This is also proven by the distance from here to there. It's also 1. That is the radius of the circle. And then now, in addition to this, we also have 2 points rather on the circumference of the circle, and then 1 point within the circle. So the 2 points on the circumference of the circle is point K with the coordinates X and Y, and then point L with the coordinates A and B. And then now the point M, it's along the positive x-axis. So the coordinates for that point M is A and 0. And then now we have about 3 angles that we need to talk about. The first angle is the beta angle. So the beta angle exists between this line and that line. So that is the beta angle there. And then secondly, we have the alpha angle. So the alpha angle exists between this line and that line. So it is the positive angle from the positive x-axis going all the way to the positive to line OK or KO. And then in addition to that, now if you calculate the difference between A and B, so if you subtract these two angles, because now you have something like this. This is your Cartesian plane, and then now you have angle beta here, and then you go again to have angle alpha like this. So this whole angle is alpha. Now for you to find the angle that exists between this blue line and that red line, you need to subtract this angle from that. Now bringing you back to this diagram here, to find this angle, you're going to take the difference between alpha rather, and beta. So that's why we have alpha minus beta, which gives us the angle that is between this line and that line, those two lines. All right. From here, now we can start with our proof. We know that the sine of any angle, so in this case we're going to say sine of beta, has to be opposite over hypotenuse. But there's no need for us to write this information because we all know it from Socatura. So, but anyway, sine is going to be, rather let me remove this. Sine is going to be, from this diagram, let us start with point L. So we're starting with point L. When we look at this diagram here, this diagram, it's a right angle triangle. And then because it's a right angle triangle, when we say sine of beta, our hypotenuse, our opposite rather, is going to be B. Therefore, we're going to say B over, and then our hypotenuse is OK. But then OK, it is equivalent to 1, the unit 1. So therefore, we're just going to say 1. And therefore, if we make B the subject of the formula, B is going to be just sine beta. Now we get this, we make this the subject of the formula because each and every number divided by 1, it stays the same. So we have B is equals to sine beta. We do the same thing for the cos. So cos beta is equals to adjacent over hypotenuse. Adjacent is going to be A over, and then the hypotenuse is 1 in this case as well. So therefore, A is equals to cos of beta. Now from here, we can easily take this information and indicate what B and A are equals to in this coordinate here. So we say L, which is A into B. This will now become, L is going to be the cos of beta. Because A is equals to cos beta, so we're going to replace this A by cos beta. That's why I wrote cos B there. And then we have sine B again, like that. So now we're done with this point, with this the coordinates for L. Now we're going to go and do the same thing for the coordinates of K. So now we say the sine of alpha now in this case. So sine of alpha is going to be opposite over hypotenuse. But our opposite in this case is going to be y. So it's going to be y over, and then our hypotenuse is still 1 in this case as well. So we're going to divide by 1. Therefore, y is equals to the sine of alpha. And then we do the same thing for cos. Cos alpha is equals to x over 1. So x over 1, the hypotenuse. Therefore, this becomes x is equals to cos alpha. Now, this simply means that the coordinates now for L, for K rather, for K, x, and y is going to be, now x, we know that it is in terms of cos alpha. So therefore, we're going to write cos alpha. And then now y, we're going to write sine alpha. So we say sine alpha. Now we have the coordinates of K in terms of cos alpha and sine alpha. Now we can proceed with the next step to this method. Now the next step involves applying the cosine rule. So the cosine rule, so we apply the cosine rule. Now the cosine rule from this diagram, the diagram that we have here, we're going to make KL the subject of the formula. So this distance, well, I think it's better if I highlight it. So this distance, KL, we're going to make it our subject of the formula for the cosine rule. So therefore, this simply means that we're going to have KL squared is equals to, now, because now this is our subject of the formula, it means that now on the other side, after the equal sign, we're going to have this length, which is OK, squared, plus this length, which is OL squared. So it's going to be OK squared plus OL squared. And then we say minus 2 into, we multiply by OK and OL. OK and OL. And then we say the cos of, now the angle that exists between these two sides, side OK and OL, or rather let me put it this way, the angle that exists that is opposite to this length, it's alpha minus beta. So this angle exists between, it exists, it is the opposite of KL, is the opposite angle to KL. So therefore, we're going to say minus, this is going to be equals to alpha minus beta, like that. Now, let me walk you through this to help you understand in case you're lost. Let me walk you through as to how I came out with this formula here. Now, let us go back to the cosine rule, which is this one here. Cosine rule, normally if you have a triangle, let us draw like a random triangle. Let's say you have a triangle like this one. And then on this triangle, you have side A, B, angle A, B, and C. Now, this one is going to be A, and then this one is going to be B, and then this one is going to be C. So now the rule says that if you want to make this side the subject of the formula, meaning that we're going to have a squared, which is going to be, we're making it the subject of the formula. Therefore, it simply means that we're going to have to square this side and add it to the square of that side. So we say plus, start with b squared plus 6 squared minus 2. So now you subtract 2 times, and then you multiply these two sides, which is b and c. Therefore, the cos of the angle opposite to this side, the side that is the subject of the formula, which is a. Therefore, a like that. That's why we have this rule here. Now, if you apply the same approach on this diagram here, here's our triangle. Let us first look at our triangle first before we proceed and explain why we did it the way we did. So our triangle in this case is going to be this one. So the one that I'm highlighting in green, it's going to be our triangle. So there's our triangle. And then the angle that exists between the two sides that are not going to be included in our, that are not going to make the subject of the formula is that angle there, which is alpha minus beta. Now, because we are making KL the subject of the formula, we're going to have to say OK squared plus OL squared minus 2 times OK times OL cos of alpha minus beta. That's why we have it the way we do here. All right, now we're going to proceed. Looking back in this diagram here, you can see that OK is equals to 1. So this is a unit circle. So it's a circle with a radius equals to 1. So OK is equals to 1 and OL is equals to 1. Now coming back here, we're going to substitute now. So KL squared is equals to OK, which is 1 squared, plus OL, which is also 1 squared, minus 2 times OK is 1, OL is 1 times the cos of alpha minus beta. All right, now this becomes KL squared, which is equals to, this is going to be 1, it's not going to change, 1 squared is 1, so it's going to be 1 plus 1, which is, and then minus 2 times 1 times 1 will remain as 2 times the cos of alpha minus beta. Simplifying this further, KL squared is equals to 2 minus 2 cos of alpha minus beta. Now let us name this our equation 1. This is going to be our equation 1. And then now we're going to go back to the distance formula. As we all know, the distance formula is as given on the board here. Now let us apply it on this diagram here. So we're going to find the distance of K and L in terms of the coordinates of K and the coordinates of L. So, but we already know what the coordinates of L and the coordinates of K are. So we don't have to use X and Y, A and B. We're going to use these ones there. So applying the distance formula. So distance formula. We have, so it's going to be KL. So we're also still calculating KL. It's going to be KL squared is equals to X at K minus X at L squared plus Y at K minus Y at L squared. Then we put the whole thing under a square root. Using these coordinates, so we're going to use, I repeat, we're going to use these coordinates. The coordinates of L are these ones. The coordinates of K are these ones. So this one is X at K, Y at K, X at L, Y at L. Therefore, now we substitute KL squared is going to be the cos of alpha minus the cos of beta all squared plus Y at K is sine alpha minus, and then Y at L is sine beta. And then we put a square root sign there. So there's been redundancy. There's a bit of redundancy here. The reason why I say that is because there's squared and then there's a square root sign. So therefore, we're going to remove these squares because they're not supposed to be here. Either you put squared this side and then you don't put a square root sign, or you put a square root sign and then you don't put the squared. So it's a bit of redundancy the way we did it here. So allow me to erase this. So this is just going to remain as KL and then KL like that. So now we're going to further simplify. Simplify this. KL is going to be the square root of, it's going to be a long square root. Now we're going to repeat these brackets as they are squared, cos alpha, and then repeat it again, plus multiplied by sine alpha minus sine beta. Now we have to FOIL this. All of this must be FOILed.